Covalent bond is our second type of chemical bond that we'll be discussing. A covalent bond is how water is formed by two hydrogen atoms and one oxygen atom covalently bonding together. So in our discussion today, we'll talk about what happens with electrons in a covalent bond, what category on the periodic table tends to covalently bond the most, and what are some ways to draw and solve a covalent bond. Those are our focuses. We can see these listed in the essential questions at the top. Ultimately, we want to be able to know the categories that form covalent bonds, what electrons are doing, and we want to be able to figure out as the bond is being shown, what does this little dash represent in the chemical formula. So there's a special way to write out a covalent bond including this little dash. So number 3 wants to know, well, what's the point of that dash? And finally, want to find some similarities and some differences between the two types of bonds we're discussing, ionic and covalent. Before we get to discussing covalent bond, let's revisit what an ion is and how they're used to create an ionic bond. An ion is when an atom has either gained or lost electrons. And when those electrons are gained or lost, we end up with a charge to that particle. When I have electrons that are gained, I form a negative ion, and when I have electrons that are lost, I form a positive ion. As this occurs, the ionic bond can form now that I have two opposing charges and the opposites attract. I need to have two opposing charges in order for an ionic bond to occur. Now typically we see an ionic bond form between metals, which of course like to lose electrons, and nonmetals, which like to gain electrons. These two common categories, metals and nonmetals, create opposing charges perfect for ionic bond situation. When this occurs, we say in an ionic bond, electrons are transferred. It's our key word for ionic bond. Electrons are transferred from one atom to the next. When the transfer occurs, so do the charges, causing the ionic bond. Covalent bond is a little bit different. The idea is the same, to make a new substance by joining together two or more atoms from the periodic table. However, not every single atom is likely to gain or lose electrons. It's typically unlikely for certain sets of elements to do so. We're going to see in covalent bond the most common type of element is non-metal. Nonmetals would prefer not to gain or lose electrons, but to get to full stable 8 in a different way. For example, thinking about group 4 on the periodic table, group 4 has 4 outer electrons. Thinking about how they would get to the stable 8 rule, we have to consider that they would either gain or lose 4 electrons to get to that magic number and have a full outer shell. Group 5 is also a little problematic, as they would like to lose 5 or gain 3 electrons. What we know here is the transfer of that many electrons, 3, 4, or 5, takes a lot of energy from the atom. We know atoms like to do the least amount of work possible. They are lazy. Therefore, these elements work together to become more chemically stable by sharing their electrons. And I have sharing highlighted here because that's our key word for a covalent bond and what happens to electrons. Electrons are shared typically between two nonmetals because it's much less energy than losing or gaining electrons. So full official definition of covalent bond here is that the attraction forms between the atoms when they share electrons. This here would be a great definition to star, circle, highlight, underline. This is what's happening to electrons in a covalent bond. They are being shared. The atoms are too lazy to gain or lose on their own. They need to work together to create this covalent bond. Now, just like ionic bond, the whole purpose is to form a new substance. Here, when electrons are shared, the new substance is called a molecule. You can see a little picture here of two atoms sitting down to what looks like a nice little dinner. We've got two trays of electrons, and they're reaching across and sharing. Look how happy they are, right? The purpose of covalent bond is for electrons to be shared between atoms, and the sharing of those electrons attract the atoms together, joining them, creating a brand new substance we call a molecule. Because in a covalent bond, the atoms like to share electrons, we kind of see something different happening here. We notice that a covalent bond is not only forming between two nonmetals, but it's also forming between two nonmetals of the same element. So I could have hydrogen bond together with itself. So we're going to do a little practice with that. On the right-hand side of your notes, it does ask you to figure out hydrogen's period number, group number, as well as category. So looking at your periodic table, check that out, and then determine, is that stable? So go ahead and pause and fill in the period, group, category, and then tell me, is hydrogen stable with the amount of electrons it has? So we know that hydrogen is in period 1, which means it has one ring around its nucleus. And we also know that hydrogen is in group 1, which means it has one outer electron. It is a nonmetal, and nonmetals like to gain. So hydrogen is a special case where it has one electron and wants to gain one electron. By gaining that one electron, it will be happy because it only has one energy level, which holds two electrons. Remember, that first ring is very small. The first ring can only hold two electrons. So hydrogen, while it looks like this, you think it might want to lose. It's a special case because it's a nonmetal and wants to gain one and be happy with two electrons. Most of our other elements we know need to get to stable 8 because their rings are so much larger. So here we can see the first ring only has 2 on it. The next ring holds 8, and the rings continue to grow in size as they get further from the nucleus. So let's create a covalent bond here with hydrogen. The first thing we need to do is write down the symbols for each element. So we're bonding hydrogen with itself, so I need 2 H's. And then I'm going to draw the Lewis dot diagram. And when I go and draw the Lewis dot diagram in a covalent bond, because my electrons are now being shared, I want to be able to see who has their original electrons still. So I'm going to do my first hydrogen with a regular dot. And my second hydrogen still will have 1 dot, but I'm going to leave it as an open dot. So I can clearly see these electrons compared to these electrons. So step 1 and 2 is just draw the symbol and create the Lewis dot. Nothing new. Now I need to show how are these guys going to share their electrons. So I want to redrawing this, moving any single electrons in between the 2 elements that I'm working on. So here I have 1 single electron, it's missing 1 from its pair, and here I have 1 single electron, missing 1 from its pair. So as I redraw these, I want to draw them in between the 2 elements I'm working with. So here's my hydrogen, right? This one brought 1, This one brought another. They are now in between and they are being shared. My fourth step is I want to draw a circle around each of the atoms showing the sharing of electrons is complete, giving them all that they need. We just talked about how hydrogen is small, so it's happy with just 2 electrons. So this hydrogen now has access to 2 electrons, one from itself and one being shared. I've put a circle around it because it is happy. It has the 8 that it needs. Or the 2 that it needs. Over here, hydrogen, same thing. It brought its original electron. It's borrowing 1, sharing 1 from this hydrogen. It has the 2 it wants. It too now has a full outer shell. The final step is to now draw the bond using symbols and lines. Okay, symbols of course are the letters, the H's, but a line is pretty simple. It just looks like a little dash, and that dash is used to represent one shared pair of electrons, and that's where it comes in really handy when I color code. So I can see here this is a shared pair. One H brought this electron, one H brought this electron. So I here have one shared pair in between an H on the left and an H on the right. So for step number 5, my symbols and line diagram will look something like this. H dash H. I have my 2 symbols of the elements I'm working with, along with a dash showing the shared pair that they have in between them. Finally, writing the new chemical formula, I look that I have 2 hydrogen atoms, so this is now called H2. Here's another way showing all the different steps that we had, starting by drawing the element symbol and the Lewis dot. This one particular has color codes. We use the open and the closed circle. Step 3 is to redraw them shared. So this H brought the yellow electron, this H brought the pink one. They are circled because they both have the 2 that they need to be stable. Step 5 is redrawing the element symbols being held together by the little stick. They've locked arms, they've stuck together to make the new molecule of H2. We just created what is called a diatomic element. Diatomic means 2 atoms, and so what we did was we paired the H together with itself, 2 atoms of the same element. This happens very commonly with elements in group 7. Group 7 can easily bond together with themselves. They're very close to 8 and they both have 1 open pair. So we can see here fluorine, nitrogen, chlorine, bromine, iodine. All these are part of group 7 and can join as a diatomic pair where I have 2 atoms of the same element. Go ahead and make sure you have a couple examples listed in your notes. Watch the video here and fill in what happens when I bond together 2 chlorine atoms.
2 chlorine atoms will react with one another to form a chlorine molecule. Why and how does this reaction take place? Each chlorine atom contains 7 electrons in its outer energy level. To form a stable octet, the 2 atoms have to share a pair of electrons. A covalent bond forms in the resulting chlorine molecule. The shared pair of electrons moves around both atoms.
So we can see here the shared pair is rolling around in between and back and forth the 2 joined chlorine atoms. And this is a really nice picture here because I can see each chlorine atom had 7, right? They linked together and made a shared pair. They all now have access to 8, making them both happy, linking together as chlorine and chlorine to make Cl2, another type of diatomic element. Let's try the same thing for hydrogen and oxygen. Answer those couple questions using your periodic table, and we'll get to drawing. So let's try the same thing here for oxygen, O, and hydrogen, H, starting with the Lewis dot. O is 6, oxygen is 1. I now need to redraw so I can move the single electrons between the elements and show that they're being shared. So I like to start with the biggest one, which in this case is oxygen. Starting here, I can place one H here, giving it shared electron, and I can also place one here, as those two were empty in the hydrogen outer shell. Now that they are being shared, I can circle, showing that everybody has what they need. The oxygen here has all 8, whereas the hydrogen is small and only is in need of 2. Last 2 steps are to create the bond diagram using the dashes to show each shared pair of electrons. So again, I like to start with the biggest one, O. I've got a shared pair here to the left, so I put a dash with an H. Here I have a shared pair below, dash with an H, and I name it. This is called H, 2 of them, O. Again here, another way of looking at it, this one is color-coded, so the O's brought the pink electrons, the H's brought the yellow. They've gotten circled when they have all electrons that they need. Over here, I can see the diagram showed with the shared pair for the dash, because one dash equals one shared pair. Finally, let's know that when we make a covalent bond, there's some specific properties that come to be. Typically, this is happening between 2 nonmetals because they always like to gain electrons, so it makes them really easy to share. And once the new substance is made, it doesn't matter what phase it's in. It can be a solid, liquid, or gas when it forms the brand new molecule. You do have this question written on the right-hand side asking you to compare here what happens to ionic compounds. So get back to your page on ionic compounds in your notes and give me a little statement here about something that's the same or different between the properties for the 2 bonds. Finish up by answering your 4 summary questions. What categories are likely to covalently bond together? What happens to electrons in a covalent bond? And then 3, describe for me what the dash means. The last one, you're making a Venn diagram where you have all the info about ionic bonds, all the info about covalent bonds, and then in the middle, things that are the same or properties that they share.